Tunnel modes and layer protocols. It is a one-way relationship between the sender and the receiver that affords security for traffic flow. It is defined by three parameters: security parameters index SPI, IP destination address, security protocol identifier. It has a number of other parameters: sequential number, AH and EH information, as well as the lifetime. And also it have a database of security associations. The security policy databases, that is relates IP traffic to specific areas. It match subset of IP traffic to relevant SA. It use selectors to filter outgoing traffic to map, and also it is based on local and remote IP addresses. Next layer protocol: name, local and remote port. See this diagram. It comprises of a protocol, local IP, port, remote IP, port, action, command details. For a UDP protocol, the local IP is 1.2.3.101, port 500. There is no remote IP. Port is 500. Action is a bypass action. Command IKE. For ICMP protocol, local IP is 1.2.3.101. Port remote IP details are, there is no details about the port remote IP port. Action, bypass, command, error messages. And ESP in transport mode, that is the action that is established. Command is encrypted intranet traffic. For TCP, there are two kinds of TCP used over here. 1.2.3.101 is a local IP. For remote IP, 1.2.4.10. For the port 80, it is a ESP in transport mode. Command is encrypt to server. For the port 443, action is a bypass. The command is TLS. It is mainly used to avoid double encryption process. As well as the local IP 1.2.3.101. The remote IP is 1.2.4.0/24. It is the action as discard, others in DMS. And again next local IP 1.2.3.101. Action is bypass, command is internet. In encapsulating security payload, that is ESP, it provides message content confidentiality, and then data origin authentication, connectionless integrity, and anti-replay services, limited traffic flow confidentiality. And the services that is depend on options selected when established security associations and the net location. It can use a variety of encryption and authentication algorithms. This is the encapsulating security payload diagram, which comprises of n number of partition layers. From the bottom to top, integrity check value, that is IC value, it is a variable one, as well as the pad length, next header, and then size of the padding in between the 0 to 255 bytes. TFC padding, it is it has two parameters. One is optional and second one is variable, and the rest of payload data is variable. Initialization value is 4. This one is also optional, and sequence number and security parameters index SPI. Encryption and authentication algorithms are padding. ESP that can encrypt payload data, padding, pad length, and next header field if it is needed to have an 4 at start of payload data. ESP can have optional ICV for integrity. This is very much computed after encryption is performed. And ESP uses padding process It is used to expand plain text to required length, and also it is used to align pad length and next header field. It is used to provide partial traffic flow confidentiality. Anti-replay service. It is replay is when attacker resends a copy of an authenticated packet, and also it use sequence number to thwart this attack. Here sender initializes a sequence number to 0 when a new SA is established. It increment for each packet, and also it must not exceed limit of 2 power 32 minus 1. The receiver then accepts the packets with the sequence number within the window of n minus w plus 1.